my name is Nako Nakatsuka. I'm a fourth-year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now I'm going to show you guys how to calculate equilibrium composition. So this is the problem. You have 1.5 moles of PCl5 placed in a 500 milliliter flask, and this decomposes to form PCl3 and Cl2. They give you the equilibrium constant value, 1.80, and all of these gases are present at 250 degrees Celsius. Okay, so when they're asking for the equilibrium composition, what this means is the concentration of each individual gas at equilibrium. Alright, so let's figure this out. So first of all, always write out the balanced equation. So you've seen this equation before because I did an example, but PCl5 decomposes to PCl3 and Cl2, and everything is a gas. Okay, so the initial molar concentration of PCl5 we can figure out, right? Because they give us the number of moles and they give us the volume. So it's going to be 1.50 moles divided by 0.5 liters, because remember the units of molarity is moles per liter, so you always have to convert the units. And this gives us 3.00 molar. That's the concentration, or moles per liter. So now we have to create something called an ice table. So an ice table, I stands for initial molar concentration, C stands for change in the molar concentration, and finally E stands for equilibrium molar concentration. So now let's draw this table out, and this is going to be the column for PCl5, this will be the column for PCl3, and this last part will be for Cl2. Okay, so the initial concentration of PCl5 is 3.00. Since this is what's placed in the flask, we're going to start out with 0 of the product since it hasn't started decomposing yet. So what's the change in the molar concentration? So here we have to assume that PCl5 changes its molar concentration by minus x. So for every minus x of the molar concentration that's used up, you're going to form the same amount of molar x on the other side of the product. So we're going to have plus x here and plus x here. So currently the reason why it's just minus x, and plus x is because the coefficients in front of all of the different compounds is 1 to 1 to 1. So for example, if this was 1 to 2 to 1, then this would be plus 2x, whereas everything else would just be x. So whatever the coefficient in front of your compounds, you make that reflect in this table. Okay, so at the equilibrium molar concentration, we're just going to go and add or subtract what we had before. So at equilibrium, we're going to have 3 molar minus x, whatever got used up to decompose into the products. And we're going to end up with just plus x here, 0 plus x, and x here as well. So now we can rewrite Kc, which is the equilibrium constant, as the concentration of PCl3, Cl2, over the reactant, which is PCl5. And now what we can do is plug in the equilibrium molar concentration values that we got from our ice table. So this is going to be x and x, so x squared, and this is going to be 3 minus x. And the Kc value is given to us as 1.8. So now what we have to do is solve for x. The way in which we can do that is rearrange this equation to look like this. X squared plus 1.8x minus 5.40 is 0. Doesn't this look like something from back in high school when you learned general math? Because this is a quadratic equation. And a quadratic equation can be solved by using this formula right here, where x is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So this is the common quadratic equation solution to something that looks like ax squared plus bx plus c is 0. And that's exactly what we have right here. So now we can just plug in our values. So x is going to equal negative 1.8 plus or minus the square root of 1.8 squared minus 4, 1 times negative 5.4, and all of this divided by 2a, which is just 1. The value we get is going to be 1.59 and negative 3.39, since remember there's two solutions to the quadratic equation. But since concentration has to be positive, the value of x must be positive 1.59 molar. So now that we know what this value is, we actually figured out all of the equilibrium molar concentrations. So let me write that right here because I'm running out of space. But for the concentration of PCl5, it's 3 minus x, which is 3 minus 1.59, which is 1.41 molar. For the concentration of PCl3, that's just x, so it's going to be 1.59 molar. Finally, for Cl2, it's exactly the same. It's x again, so it's 1.59 molar. So by using this ice table and also using the quadratic equation, we were able to figure out the equilibrium composition of this system. So this is a really important calculation for you guys to understand. So do a lot of practice problems yourself so you can familiarize yourself with making this ice table, and also always remember that the coefficients in front of the balanced equation has to go in as a multiple of that x.